is Mars, also known as the Red Planet. It's grabbed pretty much everyone's attention. Scientists, astronauts, teachers, you name it. But now it's time for the big question. How are we going to get to Mars? Well, first, here are some stats. It will take approximately 300 days to reach the planet. However, this depends on factors such as speed and the position of the planets. Every 2 years, Mars is at its closest point, only 55 million kilometers from the Earth. This is the ideal time to send a spacecraft. However, the furthest apart they can be is 400 million kilometers, and the average distance between the planets is 225 million kilometers. Mapping out our path involves several facts. The orbital speed, which is 14.5 miles per second, and its exact position. The Earth travels at a faster speed around the Sun than Mars does. The spacecraft will already have the 107,000 kilometers per hour speed of the Earth, whereas Mars moves at only 86,900 kilometers per hour. To allow for this, mission planners must launch the spacecraft when Mars is ahead of the Earth in its orbit. The spacecraft will catch up to Mars because of the high velocity provided by the Earth. The spacecraft must break free of the Earth's gravity. This requires a speed known as the escape velocity of at least 40,300 kilometers per hour with respect to the Earth. At a lesser speed, the spacecraft would go into a highly elliptical orbit around the Earth. So now let's talk about something called the Hohmann transfer. It is the elliptical orbit that required the least total change in velocity. However, it is also the transfer that takes the most time. But it is possible to speed up the transfer by making the first delta V higher. This results in a larger transfer ellipse. This diagram shows that when making the first delta V higher, it would result in a larger transfer ellipse. Now that's all done, we need to figure out when to launch the rocket. This figure shows the planet's orbits when we're ready to launch. But now what we're asking for is the angle between Earth and Mars, which we've named using the Greek letter theta. In order to work this out, we know that it takes 8.5 months to drift out along our elliptical transfer orbit. But the question is, how far will Mars move around its orbit during those 8.5 months? So now we need to write a ratio where t is the time spent going around and pm is the period of Mars's orbit, which is how long it takes Mars to go all the way around. This will be given by the ratio between angle A, which is 180 degrees. So we can do 180 degrees minus theta divided by 360 degrees. We know that the time it takes for us to drift around here, t, is given by 8.5 months, which in years is 0.71 years. And the period of Mars's orbit is 1.88 years. Therefore, we can substitute all these values, which should give us 180 degrees minus theta divided by 360 degrees, the total angle. This should give us an answer of theta equals 44 degrees. This means that the rocket should be launched when Mars is exactly 44 degrees ahead of the Earth in its orbit. Up until now, the idea of even going to Mars seemed like just a dream. But since space travel has improved so much, who knows, we may be living in Mars in a few years' time.